Good morning, good morning, good morning, guys. Good morning. Welcome to the fourth quarter, lesson one. The fourth quarter, lesson one. And Mr. Marvin is in here. I'm going to teach you the lesson one. And the lesson one is in the chapter seven. The lesson 7.1 is about the Romans aqueducts. Look, this is the example of one aqueduct. Look, and how this structure made to pass the water and move the water from one reservoir to the city. This is the gravity, the way how the water go down, right? Remember, if we slope, what does mean slope? Slope is when we put something in this position and then the gravity is going to move the things that I have on. For example, if it's water, if I slope this, the water is going to fall, right? And this is the way, if you see, this is not slope. It's not slope, it's like this. But the water or the reservoir or the lake of water is up. So in one way, the water go using pipes, right? Se llaman tuberías, the pipes, and go to the canals of the aqueducts and go down and then go to other aqueducts and then like this go and move the water to one place, to one lake or one reservoir, to one city. The Romans were very smart. Very smart, and they used pipes to move the water to one place to other. Look, so using canals or using tunnels and transporting the water through the cities, right? This is the way how the Romans, right, transport the water. The water goes in here in the aqueducts and then pass to other places or other parts of the city. This is the most important picture that I want you to see. You have to see. This is the reservoir or water or the lake. If you see, this is a little bit slope, and for example, this is the Roman aqueduct example, right? Intake, this is the place where the water go, right? It's like a special of tunnel, and go to the pipes, right? Or tunnels, and go to the aqueduct bridge, and then go to the city. This is the way. If you see, it's a slope, right? Yeah, it is. But the aqueduct bridge is only a little bit slope, right? The most important gravity moves, it makes moves is the position of the water that is high than the canal. If you see, this is a little bit different in the position. Now, if you see, actually, this is the way how the modern aqueducts work. The reservoir, the intake is the same. The conduct, and then use the gravity to move onto the plant treatment. Aquí es donde se trata el agua para que quede limpia, and go to the cities. This is the way how the water goes in tunnels under the soil and using the gravity. But the aqueduct bridge was an important invention when the Romans did it in the past. This is an important invention that you have to know. For the reason we are looking at Roman aqueduct, and this is the question: how do you get water to run uphill? Uphill, sorry. How do you get water to run uphill? Super difficult to understand, but with the picture that I show you, you can understand better using pipes and aqueduct canals. So 2000 years ago, the Romans Empire ruled a large part of the world. Yeah, it's true. Romans land stretched from France to the Middle East, from Egypt to England. At its height, The empire had about 55 and 65 million people living in it. Good public works were one reason the Roman Empire could become so big and powerful. For example, Roman engineers designed one of the history's greatest road system. Soldier supplies and information moved quickly through the empire. The Roman aqueducts, pay attention, the Roman aqueducts through may have been an even greater achievement. Many of the empire's citizens live in cities. Some of these cities became very large, right? Sorry, and I want to move this to show here. So, oh, sorry. Many of the empire's citizens live in cities. Some of these cities became very large in order for so many people to live in one place. They need to access to water, right? For example, Rome, the empire's capital, had a population of 1 million people. It takes a lot of water to keep 1 million people from getting thirsty, right? Rome had more than 250 miles of aqueducts that brought water to its citizens. Imagine, right? In conclusion, the reason said that a Roman Empire was very big and take most of the middle of Europe, in Egypt, the east of Europe, and grow the city and have a population of 1 million of people. So they need a lot of water to drink, and not only water for everything, right? So the Romans invent the aqueducts and did a solution to the people, right? So this is the example how this bridge work. Look, and transport the water from the reservoirs to the cities. This is the way how this work. Okay, I'm not going to read so much, just the most important to finish the reading. Aqueducts work by using gravity. This is the most important part. As long as the aqueduct slopes downhill, the water keeps flowing. Obviously, right? If you slope something, the gravity is going to do its job. The Roman engineers had to be careful way to a city. Sometimes water had to flow from lake or spring that was many miles away. The engineers built aqueducts to slope only a couple of feet every mile, not too much, only a little bit. Because if you put it like this, in winter, when it's going to rain a lot, the city is going to have a lot of water. So, más bien se iba a inundar, porque si le ponían mucha inclinación, iba a ser un problema. So, the engineers think they were very smart, and they said only a little bit per miles to slope, right? So, every mile, they slope a little bit, only a little bit. Aqueducts often cross valleys and went through mounds. Water could flow right through a mound. If a tunnel was dug via tunnels to right the water go. If a valley was not too deep, a bridge could be built, right? Or they use bridge or tunnels. So Romans engineers use pipes. What is a pipes? I show you one pipe. Pipe is, in this case, we know as plastic, right? And the water go inside. So the pipes, as it hit downhill, the pipe narrowed as it made its way down into the valley. This create pressure, and this pressure pushed the water uphill as it's headed back out of the valley. So the last part of the reading said, the Roman aqueducts were used for hundreds of years in several European cities. These historical stone structures still stand tall as reminders of a time when the powerful Roman empires ruled. So these bridges are already, ahí están todavía, esos vestigios de los acueductos. Super important invention, super incredible, amazing, awesome invention of the Romans. So the classwork is to answer these questions. Pay attention. We have to answer the questions. Your name, don't forget your name. In this part, your name, right? Circle the letters of the best answer to each question below. How were the Romans aqueducts able to carry water over long distances? Option A, they used pumps. Option B, they used tunnels. They sloped. All of the above, right? I think is how were the Roman aqueducts able to carry water over long distance? I think is they slop a little bit, right? So, number two, the tunnels is able. They use tunnels can be an answer to. Number two, which of these statements is still true today? The Roman Empire rules most of Europe. Cities no longer use aqueducts to get water to their citizens. Water flows downhill because of gravity. Water flows uphill in tunnels. I think it's the letter C. Water flows downhill because of gravity. Obviously, this is the most important. The Roman Empire took most of the European places in the past. Not actually. Actually, Rome is only a little bit country, right? And is Italy, most of Italy, the capital, you know. But in the past, the Roman Empire was very big and took almost the middles. I already said the middle of Europe. Pero ahora ya no. Ya ahora está England, is Spain, and other countries, you know, different countries of Europe, and Italy is only the one that take Europe, the Roman, or a little bit of Rome, right? So water flows downhill because of gravity. This is the answer. And the last question, the last two to finish the reading is sorry. I have a new mouse and this mouse is not working so well. So the last question is, give me a chance. I want to move this. Why were most of the aqueducts underground in the capital city of Rome? Why were most of the aqueducts underground in the capital city of Rome? Underground. Option A, the water stay warm. Option B, the water stay clean. Option B, water flows more quickly in tunnels. All of the above is the letter C. Water flows more quickly in tunnels. And the last one is, write in your warm words or write in your answer on the lines below. What do you think will happen? It's super easy. If a city did not have a good system of getting water, in Honduras we don't have a good system of water. For the reason most of the places we know as colonias, they don't have water in the capital, Tegucigalpa. What happened if a city did not have a good system for getting water to the citizens? What is a citizen? Ciudadanos, the citizens, right? You and me are citizens. Bueno, we are citizens. You're going to be citizens after the 18 years old, right? In Honduras. So what is going to happen? We're not going to have water, and the people is going to be with different problem, right? So this is the lesson. Try to answer. I have 30 seconds. I love you so much. Bye bye. Lesson 1. Do the classwork and see you in the meet. Bye.